Please briefly summarize your industry education, professional background, and current role at OHM.
My name is Jason Griffin. I have a Bachelor of Science in Civil Engineering from Tennessee Technological University in Cookeville, Tennessee. I am a Tennessee native and someone that, really enjoys creating relationships and serving others. That's really provided me with a very good understanding of community needs, especially those focused, over in the water industry. My role at OHM Advisors is in the Tennessee market leader role. As the market leader, I am charged, more broadly with our mission of advancing communities and our clients across numerous disciplines. While my experience really is rooted within the water and wastewater utility systems, that really tends to direct my attention more to supporting those type of clients.
And my name is Helen Scales, and I serve as a senior GIS analyst for our offices in Nashville, Knoxville, Louisville, and now Frankfurt. I have a background in environmental science and geoscience. I got my bachelor's in geoscience and environmental science at the University of Tulsa, and my master's in public affairs and environmental science at Indiana University. And I just had a passion for GIS since the beginning of my education and into my career. So I've been working with countless communities, bringing them up to speed with GIS and how it can be useful for clients, utilities, and even internally for OHM.
How does OHM fit within the infrastructure industry? And please cite some recent examples.
Fitting into the infrastructure industry, OHM Advisors provides a broad array of municipal infrastructure planning, engineering, surveying, and construction management services. Specifically here in the Tennessee market, we're doing sewer system planning over in East Tennessee in the Bradley County region, specifically for the Ocoee Utility District. This even entails permitting for a brand new wastewater treatment plant discharge. We're also wrapping up the design of a water treatment plant for the Ocoee Utility District. Water system hydraulic modeling and capital planning is something that we do for a lot of clients, and specifically we're doing that right now in Portland, Tennessee. We're using that hydraulic modeling and capital planning to lay the basis for a new water tank, designing new water transmission mains. We're even doing collection system work, designing new gravity sewers that are associated with a lot of residential development. We are also contracted with the city of Nashville to provide construction engineering inspection for an array of public projects that include sidewalks, roundabouts, water and sewer system improvements, and inspecting new water meter installs that are associated with the vast amount of new residential and commercial development in the Nashville area.
So what are some current difficulties in water system infrastructure? How can technology help improve them? And how might GIS play a role?
So the difficulties right now within water system infrastructure, I think the broad answer to that is the aging infrastructure issue. And that directly impacts or will cause water loss, increased power consumption, and overall can decrease water quality. I mentioned earlier, hydraulic modeling and GIS that we're using as a baseline tool. OHM's client base has been introduced to the benefits of utilizing this technology for many years now, and we're advancing that. And Helen, you may want to comment a little bit more on that.
To piggyback off of what Jason said, one of the hugest or the biggest issues with infrastructure is that it's aging, and we don't know exactly where that aging infrastructure is or what's causing it. GIS provides spatial awareness to infrastructure information. You can visualize where the aging infrastructure is in relation to other factors like environmental factors or population characteristics. And it allows you to visualize trends or hotspots where crucial data is missing or where infrastructure is failing, and then those underlying causes. With new funding available for specifically asset management and GIS, it's becoming more accessible for a wider array of communities. And the new focus on cloud-based data and data sharing is really allowing for data to be shared across multiple communities, multiple clients, from federal all the way down to neighborhood level. I'd like to add and reiterate how accessible GIS is for everyone. Now that it's cloud-based and relatively inexpensive, I think a lot of utilities that we've seen are hesitant to adopt GIS because they think that the learning curve is pretty steep. But now with multiple tutorials online from software companies, as well as engineering companies like OHM Advisors, that training is pretty minimal and can greatly increase the utility of your system.
Helen, could you share me just maybe one example of somehow like these technologies being tied up, like the GIS and then the cloud computing and how it's actually being used?
Traditionally, GIS information has been stored locally. You have one specific file for, say, water mains, one specific file for valves, and not much information associated with each feature in that data. Now with cloud-based data and management, these features can not only be shared in live, edited live by multiple people, it can also be associated with inspection information, photos, videos. Specifically, OHM Advisors has been attaching 360 images and videos to manhole inspections and other asset inspections, which allows for basically in-person inspection to be done on the desktop as opposed to having to send out a crew into the field. So cloud-based technology is really making inspections as well as asset management a lot more efficient than it used to be in years past.
Are master plans one of the best ways to improve infrastructure of all types? Why not? And please cite some specifics.
Master plans are a great way to plan for infrastructure improvements. There's a saying that a failure to plan is a plan for failure. Master plans can be really effective tools, using them for both proactive and reactive circumstances. An example of proactive is you're planning for system growth in which you know one day you're going to need new utility easements. You've looked at the basin, you've identified corridors of growth, and so you may need to go ahead and acquire those easements, even though you're not putting utility lines in yet. Same thing for property acquisitions for above ground infrastructure like treatment plants, pump stations, water tanks, going ahead and grabbing those properties well in advance today instead of waiting into the future. A reactive situation from a planning perspective is you've got a water line that gets washed out during a flood. So your immediate need is to go out and put that water line right back in. Well, if you've done the proper planning, you've done your modeling, you've looked at your future growth, you may have already identified, well, that line needed to be upsized in the near future. So instead of reacting and then just putting back in kind what was there, you need to maybe increase the size of that line when you go to replace that after a natural disaster or something of that nature. So a pump may fail. And again, you forecasted increases in capacity. Instead of just replacing that pump with what was there, you may need to add a larger pump with a VFD. Nobody has a crystal ball, but forecasting and planning for capacity growth is really critical to utility management and best finance practices.
Can you again cite another specific example of how the current technology is helping to do a better master plan as opposed to just, as you were talking about, just reacting to the way things are coming in and out? Like, how is the technology really helping there?
So the technology has advanced well beyond, when I first started doing this over 20 years ago, we really weren't into the GIS world. That was not available. We were using a lot of older technology for base maps, and being able to have the database of information. So today with GIS, we have so much more information readily available when we are doing our analysis, when we are constructing our hydraulic models. We now can link the modeling information directly into GIS and pull in that asset information across, so that when we are looking at future growth corridors, we've got so much more information in front of us today than we did even 10 years ago. But for me, 20 years ago when I first started, it's come a long way in that regard.
I think GIS is improving master plans by making them more robust as well. We're adding information that would have just a few years ago been very difficult to process, but now it's publicly available. For example, tiger census data from FEMA, data from the EPA is now all available and live streamed online from the cloud. So instead of having to export flood information or wetland information directly from FEMA, now we can live stream it into the model to predict where you're going to see these leaks or failures. The same goes with census data. Now we can see where critical populations lie, as well as where the population is growing. You can add that temporal trend to flood information and into census information and predict where your plan needs to focus in the future.
So as it's always a concern for everyone involved in infrastructure, can you provide some advice to overcome funding challenges that maybe you've come across in your careers?
One of the biggest funding challenges right now for utilities is user rate resiliency. A lot of systems tend to refrain from annual rate increases, and when they go to have major capital improvements and needing funding, that funding requires financing typically. And if they haven't performed any rate increases in recent years, the term rate shock comes into effect by the users. So utilities really need to take advantage of setting up annual rate increases, even if they're as small as 1%. You've got opportunities right now that, with interest rates and things in the economy that are changing rapidly, utilities really need to think about locking down long-term financing. And that can be done through low interest programs, through the federal government, or municipal bonds. We're still in a really good period to lock down low interest rates. I mean, rates are rising, but it's still a good time for folks in the utility industry to really focus on securing long-term financing. The government is not going to be able to fund all of these projects with grant proceeds. And honestly, most systems are not going to be eligible for those grant proceeds that the government is putting out. Relative to funding challenges, utilities should also examine their fee structures to supplement the user rates, especially in the areas of residential and commercial development. For systems that are experiencing urban sprawl, the impact of large-scale developments, on a system capacity can be an enormous financial burden to levy across the existing user base. OHM Advisors is assisting our clients right now through evaluation processes that take information from hydraulic modeling and GIS, to assign capacity fees for proposed development corridors. This strategy can really add a significant amount of needed revenue for those capital projects that are focused on increasing capacity.
So what should our engineering audience be thinking about in terms of water systems master planning, and the best use of technology?
Water systems, should be taking steps to better understand their system. Going forward, we've got to get the most out of what we already have. I mean, we really can't afford to install all new infrastructure for every solution. Technology exists to create very simple tools to document, forecast, and plan our system growth. Utilities need to leave a legacy of proactive management.
Engineers should be thinking about how the vital information that they're developing on their water systems and for utilities can be translated into a useful format for staff and citizens. And GIS often bridges that gap. The more people that understand the complex analysis that goes into a water model and forecasting and planning, the more useful it's going to be, and the more likely it's going to be sustained for multiple years and by the utility or community themselves. Additionally, I think that engineers should draw information from utility staff and clients themselves, and you can do that by using GIS. GIS now allows information to be gathered from a wide array of sources, even from the public. So sharing data is crucial for its upkeep and maintenance because it's a constant battle to keep it updated and useful for years to come. And it's one of the most important aspects of applying for grant funding. The more information you have and the more in-depth it is, the more likely that you are to get funding for future projects.